To graph the tangent and cotangent functions, we are going to first start off filling out our table with the sine and cosine of some different angles. And I know this table is a little bit different. I have some negative angles as well as some positive radian measurements. So I've gone through, I filled out the sine of each of these angles and the cosine. And remember that the tangent is equal to sine over the cosine. And this is because if you remember, tangent is y over x. If you're looking at a point on the unit circle with the coordinates x, y, the tangent of that particular point or that angle with this terminal point is the y coordinate divided by the x coordinate. Well, the y coordinate we know is sine, the x coordinate we know is cosine, so that's why tangent is sine over cosine. So in order to fill out this particular table with the tangent of these angles, then you can just use sine divided by cosine. So 0 over negative 1 is 0. Negative root 2 over 2 over negative root 2 over 2 is a positive 1. Negative 1 divided by 0 is undefined. Negative root 2 over 2 over positive root 2 over 2 is negative 1. We have 0, 1, undefined, negative 1, and 0. And then I can do the same thing for cotangent. Remember that cotangent is the reciprocal of tangent. So if tangent is sine over cosine, cotangent is cosine over sine. So that means I'm going to take the cosine over the sine. So negative 1 over 0 is undefined. So the cotangent of negative pi is undefined. Negative root 2 over 2 over negative root 2 over 2, that's still 1. Or you could go through, obviously, and you could do the reciprocal of just your tangent function. But it makes it a little bit harder to do something like the reciprocal of undefined. So instead, that's why we think of 0 over negative 1 is 0. We have positive root 2 over negative root 2 over 2. That's going to be negative 1. This one's going to be undefined. The reciprocal of 1 is 1. Reciprocal here would be 0, negative 1, and then undefined. So now we're going to take all of these values in these two rows and we're going to make our graphs. So the first graph I want to look at is the tangent function. So y equals the tangent of x. And you'll notice I set this up so that I have all my negative and all of my positive angles from our table in this graph below. So if I'm looking to graph the tangent, that means I'm focusing, let me go ahead and I will highlight this. I'm focusing on this row right here for the tangent of this particular angle. Whoops, I don't know why that went away there. So the tangent of negative pi is 0. So at negative pi is 0, we would have a point. At negative 3 pi over 4, it's 1. So that's going to be up here. At negative pi over 2, the tangent of negative pi over 2 is undefined. So that is actually where we are going to see a vertical asymptote in our graph. Negative pi over 4 has a tangent of negative 1. The tangent of 0 is 0. The tangent of pi over 4 is 1. The tangent of pi over 2 is undefined, so again, we would have a vertical asymptote. The tangent of 3 pi over 4 was negative 1, and the tangent of pi was 0. So you might be wondering, how do I connect these? So first of all, the graph appears between, or one period of the graph appears between two vertical asymptotes. So this right here counts as one period of the tangent function. So how I'm going to connect it, I kind of connect it as if I would half of a parabola. So this kind of looks like half of a parabola opening up, and then over here it looks like half of a parabola opening down. That's kind of the shape of that graph. So over here I can see part of this graph over here. Now it does technically continue this way, so it would keep going. And then over here I can see this part of that period, and like I said, it would go this way as well. So these would repeat over and over and over. But this section right here, from this vertical asymptote to this vertical asymptote, this distance in here, this is one period of the graph. So what is that period? Well, I have pi over 2, a distance of pi over 2 here, and a distance of pi over 2 here. So total, this is a distance of pi units. So the period for tangent is actually pi. And I know that we're used to seeing 2 pi as the period for sine and cosine functions. So this is your general, your parent function for the tangent graph. So let's also look at cotangent. So in this part, we are going to focus on cotangent. So if these are our angles, then our cotangent is down here. So we can plot all of our points. So the cotangent of negative pi is undefined, which means the vertical asymptote will be here. The cotangent of negative 3 pi over 4 is 1. The cotangent of negative pi over 2 is 0. The cotangent of negative pi over 4 is negative 1. The cotangent of 0 is undefined, so there would be a vertical asymptote on your y-axis. At pi over 4, the cotangent is 1. Cotangent of pi over 2 is 0. Cotangent of 3 pi over 4 is negative 1. And the cotangent of pi, again, is undefined. So again, our period is between these two asymptotes, or any two vertical asymptotes. That's a full period of the cotangent function. And how we're going to connect these points is the same way, but this way it's kind of going down from left to right. So we have part of our, it looks like half of a parabola opening up over here, and then the other half opening down over here. And again, that would be the same thing over here. So again, since it goes from here to here for one period, that is a distance, a horizontal distance of pi units. So the period of the cotangent function is pi. So in general, how can I do this quickly? Because I showed you how we could do these fairly quickly using sine and cosine. So in general, tangent is the only graph that's going to start off a little bit differently because the tangent function is always going to be centered around the y-axis. So when I set up the tangent graph, so this one's going to be y equals the tangent of x, I'm going to still use 4 tick marks down here on the y-axis, but 2 of them are going to be to the left and 2 of them to the right of the y-axis. And then based on my amplitude or my stretch or vertical stretch or shrink of the graph, not really an amplitude because it's not a wave, but I'm going to put my 2 tick marks on my y-axis as well. So in general, the period, you have to remember the period is equal to pi units. So half of that period shows up over here and half of it shows up over here. So the 2 tick marks on the ends, we're going to label with half of the period. So if the period is pi, this tick mark is half of pi, or pi over 2. So then this one is negative pi over 2. So then half of that is pi over 4. So this one's negative pi over 4. And with tangent, our vertical, if there's no vertical stretch or shrink, I know that I'm going to have some points that have a y-coordinate of 1 and negative 1. So the way that I'm going to start with tangent is I put my vertical asymptotes on the 2 ends because the graph is going to show up between here. And then the graph goes up from left to right. So the first point is down here at negative pi over 4, negative 1. Then we have a point at 0, 0, and then pi over 4, 1. And then I can connect the points in the ways that I showed you. So the key really is that initial setup, the 2 tick marks to the left of the y-axis, 2 to the right, and then these tick marks here. All of these can be adjusted based on the equation. So just like the A, B values, all of those impacted our graphs for sine and cosine. We'll do the same thing here for tangent and cotangent. Now the cotangent function, I'm going to still set up the way that I was setting up all of the ones for sine and cosine. So I'm starting off with my 4 tick marks still to the right of the y-axis. I'm still going to label that 4th tick mark with the period. So again, it's important to remember that the cotangent has a period equal to pi. So this one would be pi. So half of that here would be pi over 2. Half of that is pi over 4. So 1 pi over 4, 2 pi over 4. So this is 3 pi over 4 here. And then 4 pi over 4. This is 1 and negative 1. So here, the way that you're going to graph it is, again, you're going to start and end with your vertical asymptotes. So starting and ending with my vertical asymptotes. And then cotangent goes down from left to right. So I'm going to start at pi over 4, 1, pi over 2, 0, and 3 pi over 4, negative 1. So it's going down my points from left to right. It's just all about how you connect them. So again, it looks like half of a parabola opening up, and then here it looks like half of a parabola opening down. So as long as you can set up in general what these look like to start off, then we manipulate these the same way that we've been. So if we wanted to graph y equals 2 times the tangent of x, well, the 2 is my a value. And so here, we're not going to say, like I said before, we won't call this an amplitude because we don't have a wave. We only talk about amplitude when we have the height of a wave. So this 2 is actually, we're going to call it, when we're talking about tangent and cotangent, we're going to call it a vertical stretch or shrink. So if it's a 2, it's going to be a vertical stretch by a factor of 2. There's no b value, so the period is still going to be what it was for our parent function, which was just pi. There's no numbers being added or subtracted at the end. So there's no vertical shift and there's no phase shift because there's nothing being added or subtracted to x. So to start with tangent, remember tangent, we put the y-axis in the middle, and then I put 2 tick marks on either side of it, and then these 2 as well. So since the period is pi, half of that gets marked over here, which is pi over 2. So this is negative pi over 2. Half of pi over 2 is pi over 4. So this is negative pi over 4. Now, because of the vertical stretch of 2, I can relabel these instead of 1 and negative 1. They can be 2 and negative 2. So when I graph, I start with my vertical asymptotes on the ends. And remember, tangent goes up from left to right. So I'm going to start down here at negative pi over 4, negative 2, 0, 0, and pi over 4, positive 2. And then we make sure to connect those, how we know it should look. And just like before, remember that you can check a point. So get in that habit of checking something like 2 pi over 4. If I plug that in, that's 2 times the tangent of pi over 4. Well, pi over 4 has the terminal point root 2 over 2, root 2 over 2. So this over this, it's 1. So this is 2 times 1, which is 2, which means it checks out. So, whoops, I wrote that point down completely opposite. So this is pi over 4, 2, not 2 pi over 4. I can't believe I wrote that. So let's fix that. That's better. So I'm plugged in pi over 4, and we got out 2. Let's try another one. In number 2, we have here that this negative sign, this is like a negative 1 being multiplied by our tangent function. So this is going to be a reflection over the x-axis. The vertical stretch or shrink doesn't exist. It's going to be the same as that parent function. The plus 2 at the end, this is going to shift up 2 units. So again, we're going to start this off where the y-axis is in the middle. I have my 2 tick marks over here and 2 over here. Because there was no b value in front of that x, it was just 1. That means that the period is still equal to pi. So that means this would still be pi over 2 and negative pi over 2, and then pi over 4 and negative pi over 4. But now when I'm labeling these tick marks on the y-axis, it shifted up 2. So that means that this midline is at 2, and then our it's only 1 unit away because the vertical stretch or shrink is just a factor of 1. So this is going to be at 3, and this is going to be at 1. So when I start to graph, the ends are my vertical asymptotes, but this is a reflection. So before, I would have had a point down here, here, and here. So this point will stay put, but this point below the x-axis will now reflect up here. And this point that was above will now reflect down here. So honestly, this graph almost looks just like a cotangent function because it goes down from left to right when it's a reflection over the x-axis.